Hello students, how are you? In this lecture of chemical kinetics, today we will see significance of a rate constant. In previous lecture we have seen what is the rate constant and what are units of rate constant in zero order reaction, first order reaction, second order reaction, etc. अब इसका महत्व क्या है? रेट कांस्टेंट का महत्व, an importance and a significance of what? A rate constant. How to decide this? For this I have taken general reaction. Here capital A and capital B, these two are reactants, small a and small b, coefficients of these, yani moles, number of moles of capital A and capital B. Now, how to write rate law for this? We know that rate of reaction is directly proportional to concentration of reacting molecules. Here concentration of A to the power A into concentration of B to the power B. Remember this equation is said to be rate law. हमने देखा है पिछले लेक्चर में. In previous lecture, what is the rate law? It is simple mathematical equation in which rate of reaction is expressed. Here capital R indicates rate of reaction. It is expressed in terms of concentration, this square bracket and a concentration. Square bracket का मीनिंग फिजिकल केमिस्ट्री में कॉन्सेंट्रेशन होता है, ऑर्गेनिक केमिस्ट्री में ट्रांजिशन स्टेट होता है, अनस्टेबल ट्रांजिशन स्टेट, एंड इन इनऑर्गेनिक केमिस्ट्री में उसका मतलब होता है कोऑर्डिनेशन कंपाउंड यानी कॉम्प्लेक्स कंपाउंड. हियर दिस इज द ब्रांच ऑफ फिजिकल केमिस्ट्री, सो हियर द मीनिंग ऑफ स्क्वायर ब्रैकेट एंड कॉन्सेंट्रेशन. सेम इक्वेशन वी कैन राइट R is equal to K into concentration of A to the power A into concentration of B to the power B. R and a rate of reaction K and a rate constant. ये rate constant है. अब इसका significance निकालना है हमें, isn't it? So don't worry. Suppose concentration of A is equal to concentration of B and suppose it is unity. It is a unity. So same equation we can write R is equal to K into 1 to the power A and 1 to the power B. Because here concentration of A and concentration of B we have taken equal, that is unity, 1 to the power A and 1 to the power B. So 1 to the power A and 1 to the power B. What is 1 to the power N? It is 1. So this term will be 1 and R is equal to K. Here it is a K because this term will be 1. And here rate constant is equal to rate of reaction. When concentration of reacting molecules is unity, then here rate constant is equal to what? Rate constant is equal to rate of reaction. A rate of reaction. So we can calculate a rate of reaction by using rate constant. And here it is the first significance, that is here we can calculate rate of reaction. A rate of reaction. This is the first significance of this rate constant. Now I will take two different reactions. Suppose reaction A2 product and B2 product. Here A is reactant, B is reactant for a second reaction. Here it is the first and here it is second. Write a rate law for these two equations. What is the rate law for equation number 1? It will be R1 is equal to R1 and a rate of reaction in case of what? First reaction. R1 is equal to K1, rate constant for first. Here it is K1, here it is K2. Concentration of A, equation 1 होगा. Exactly write down a rate law for second equation, that is R2 is equal to K2 concentration of B. if concentration of A equal to concentration of B, concentration of A equal to concentration of B, then compare these two. So R1 by R2 is equal to what? K1 by K2. We'll get this relation. And here we can compare R1 and R2. So by using K1 and K2 and by using rate constant, we can compare R1 and R2 and rate of reaction of first reaction and rate of reaction of second reaction. And there is a comparison. And we can study, we can predict which one is a fast reaction and which one is slow reaction. So this is second significance. So here we can compare and we can predict. We can predict fast and slow reactions. We can predict fast and slow reaction. So by comparing these two, we can predict fast and slow reaction. This is second significance of this. First, we can find out rate of reaction. And remember, when rate of reaction is equal to rate constant, so this rate constant is also known as specific rate constant. Specific rate constant. Yani we can predict specific rate constant by using this rate constant, by using this rate law. Second significance, by comparing these two, here we are taken different reactions. R1 is equal to K1 into concentration of A. This is the rate law for first reaction. R2 equal to K2 concentration of B. This is the rate law for second reaction. Here we have taken concentration of A equal to concentration of B. Then from these two equations we can write R1 upon R2 equal to K1 upon K2, and there is a comparison between rate constant, comparison between rate of reaction. And by using this comparison we can predict which one is a fast and which one is slow reaction. This is important significance of rate constant. And so here we can decide fast and slow reaction. It means that we can predict mechanism of reaction. Yani third significance, we can predict mechanism of a reaction. We know that is rate of reaction depends on what? Slow step. And slow step is a rate determining step, isn't it? And these are the significance of what? Rate constant. Number one, we can predict the rate of reaction. Number two, we can predict slow and fast reaction. And by using this comparison, we can study the mechanism of reaction. So these are the important significance of rate constant, isn't it? So we can decide by using comparison, by using composition of reactions, by using single reaction, we can decide it. If in a doubt, you can put your doubt in this comment box. Definitely I will back to you. Thank you.